Here we've got a solar electric system up on top. This is actually the largest solar electric system in Quebec for residential side. And we've got 240 watt panels, and we have 60 of them here. And the annual production is predicted to be around 14,500 kilowatt hours. So that may not mean much, but to give you an idea that the average home in Quebec uses 250 kilowatt hours of energy per meter per year. Per meter squared per year.
Electric heating or?
Electric or gas on average converted, that's the average. And so that's to give you an idea of how much we use. So, but here,
how many panels does that use?
Far more than you can fit. If you imagine that this building is only using 24% of normal, you can imagine it would be almost impossible. In fact, it is physically impossible if we just built like standard to actually produce all our power on site, because there's no more room. We use all the space that's available. So it's only if you significantly reduce energy consumption is it even possible. Physics, actual physical space. There would not be enough physical space to generate all the power on site unless you significantly reduce the amount of requirements. So,
just calculating throughout the year, would it add up? Like because of the summer and then the winter, it still would be physically impossible.
It would be physically impossible. It is not possible. This building is only using, about 1/4, and it is taking up all of the three-dimensional space that's available above this building.
You'd have to cover all those roofs.
I'd have to buy all the space on top to do it. I'd have to be a system that is as big as all of these three houses all the way over to there if it wasn't, the cost would be prohibitive. So it only works to reduce significantly the loads, and then you can consider producing energy on site. That's why the most important measures are actually the things that are hidden. The reason we did a building to be 100% solar is not because it makes sense for every building to be 100% solar, but if you just copied all the measures that took us to 24% of normal before we even put the solar on, that's the most efficient thing to do. And the solar is actually the most expensive thing, but it works because we've done all these other measures. So the reason we're doing it is to learn ways to raise the bar and learn ways to do it simpler, really efficient construction. For instance, the insulation in the envelope I was telling you about before, it's actually really simple. But usually to achieve the same envelope in the past, we've done much more elaborate, complex ways of building it that were much more expensive. So just to get back to the solar, we've got solar electric here, and then we have solar hot water. So these panels here are solar hot water panels, and they're producing 100% of our hot water needs in the winter, and we actually have a surplus in the summer, which will be transferred to the second building that we're building. We have the solar electric system.